We are solving now question number 5 of this mechanics paper 2023 May June. Four coplanar forces act at a point. The magnitude of the forces are F Newton, 10 Newton, 50 Newton, and 40 Newton. The direction of the forces are shown in the diagram. Given that the forces are in equilibrium, find the value of F and theta. Since there are four forces acting at the point, let's say that is the point O, and they are in equilibrium. So you are going to solve them into the components. F force will be resolved into two components. It would be F sine theta, and this would be F cos theta. This 40 Newton is also resolved into two components. This would be 40 sine of 60, and this would be 40 cos of 60. Since these forces are in equilibrium, so for the horizontal forces, there is F cos theta and 10, they are acting in one direction, which is being balanced by 40 cos of 60. So F cos theta is equal to 40 cos of 60 minus 10. So 40 cos of 60 is 1 over 2 minus 10. So that thing is equal to 10 Newton is the horizontal force of that component there. Then vertical forces, they are also balanced. So here vertical forces upward is F sine theta plus 40 sine of 60, and that is balanced by this 50. So F sine of theta is equal to 50 minus 40 sine of 60, that is root 3 over 2. So that is 50 minus 20 root 3 Newton. Now, you are going to find out the value of F and theta there. Let's say this is force 1 and this is force 2 there. So dividing F sine of theta by F cos of theta are 1 divided by 2. So F sine of theta over F cos of theta is equal to, sine theta is basically equal to 50 minus 20 root 3 divided by this 10. So F and F cancel. Sine theta over cos theta is basically equal to tangent theta. 10 5s are 50 minus 2 root 3. So theta should be equal to tangent inverse of 5 minus 2 root 3, and that is equal to 59.56.9. That thing is equal to 56.9 degrees. That is the angle value theta there. And now you are going to calculate the value of F. From this 1 and 2, we know that if we make it F square sine square theta plus F square cos square theta, then it should be equal to F sine theta whole square, that is equal to 10 whole square plus F cos theta whole square. F cos theta is basically equal to 10 and F sine theta is basically equal to 15.358, and this is square. Here F square is common. It is cos square theta is equal to 10 square plus 15.358 square. Since sine square theta plus cos square theta is equal to 1. So F square is equal to 10 square plus 15.358 square. Our F value will be equal to the square root of this value. Three 35.8 square root. It is 18.32. So this is the value of F, and that is the value of theta there. So these are the two calculations which are going to be solved in this first part, that find the value of F and theta there. Part B now. Given that the value of F is 10 root 2 and theta is equal to 45, find the direction and the exact magnitude of the resultant force. Now, because they are asking for the net resultant force and the direction, So we are going to resolve this part into fx, the all horizontal components. That should be equal to f cos of theta plus 10 minus 40 cos of 60. But f there is given equal to 10 root 2 into cos of 45 plus 10 minus 40, and cos 60 is basically equal to root 3 over 2. So 10 root 2 into cos of 45 is 1 over root 2 plus 10 minus 20 root 3. This root 2 and root 2 cancel. So 10 plus 10 is 20 minus 20 root 3. This is 40 cos of 60 is basically 1 over 2 there. So this should be equal to 10 root 2 into 1 over root 2 plus 10 minus 20. This thing will be equal to 20 minus 20, and that thing is equal to 0. So all fx component resultant is equal to 0 there. Now you can find out fy, which is equal to containing all the vertical components. It should be equal to f sine of theta plus 40 sine of 60 minus 50. F there is 10 root 2 into sine of 45 plus 40 sine of 60 is root 3 over 2 minus 50. This is 10 root 2 into 1 over root 2 plus 40 root 3 over 2, that is 20 root 3 minus 50. This root 2 and root 2 cancel. So it should be 20 root 3 minus 50, and this is plus 10, so minus 40. And that thing is all vertical components. Since we know one thing, that if fx and fy are there, they are both positive, then the resultant is in this direction. If fx is negative and fy is positive, then it is in this direction. When fx and fy, they are both negative, then they are in this direction. And when fx is positive and fy is negative, then it is in this direction. But when fx is 0 and vertical component is there 20 root 3 minus 40, so it means our net resultant force is basically equal to fx square plus fy square whole square root. So this thing should be equal to fx is there equal to 0 plus fy there is 20 root 3 minus 40 whole square. So net resultant force will be equal to 20 root 3 minus 40 in that. This is the magnitude of the total resultant force of this all forces at O there. Then the net resultant direction, that is theta, is equal to tangent inverse of Fy over Fx. This means tangent inverse of Fy there is 20 root 3 minus 40 divided by 0. That means theta is equal to infinite tangent inverse of infinity. That means it is acting along the direction of y-axis, which is downward to that, or it is in the direction of 50 Newton force of this value there. So this is the solution of this part B there, where you are going to find out the net resultant force and the net resultant direction. So for the direction, you have calculated it equal to infinity, and that tangent inverse of infinity is either at 90 or at 270 degrees. But here it is negative to that part, so it is in the y-axis direction downward and along the direction of the force of 50 Newton there. Two particles P and Q of masses 0.2 kg and 0.1 kg respectively are attached to the ends of a light inextensible string. The string passes over a fixed smooth pulley at B, which is attached to the two inclined planes. Particle Q is lying on the smooth horizontal plane AB, and which is inclined at 60 degrees to the horizontal. Particle Q lies on the plane BC, which is inclined at an angle of theta to the horizontal. The string is taut and the particles can move on this line of the greatest slope of the two planes. It is given that theta is equal to 60 and the plane BC is rough. The coefficient of friction between the particle Q and the plane BC is 0.7. The particles are released from rest determine whether the two particles move no components of this one is this is R mg cos, or you can simply write this thing as R, and this one is mg cos of theta. This would be mg sine of theta. This tension is same as this tension, directed towards each other and have equal magnitude. This is R1, this is, let's say, R2, this is M1G cos of 60, and this one is M1G sine of 60. But this surface A to B is rough, so mu is equal to 0, and BC surface is having a friction which is mu is equal to 0.7. So this frictional force acting along this direction there. We know one thing, for this particle P, tension is M1G sine of 60. minus tension T. Main equation is driving force minus resistive force is equal to net force. So driving force here is m1g sine of 60 minus this tension T is equal to m1a. So m1 is 0.2 into g is 10. Sine of 60 is root 3 over 2 minus this tension T. m1 is 0.2 into acceleration a, and let's say that is equation number 1 now. For this particle q there, it is moving upward and this is moving downward. So here the tension is T there minus the weight component, that is m2g sine theta plus frictional force is equal to 0.1 into acceleration a there. So tension minus m1 is 0.1 into g is 10 into sine of 60 is root 3 over 2 minus, this is plus frictional force. We know that frictional force is mu r, mu is 0.7, r is mg cos of theta, or that thing is equal to 0.7 into m, that is 1, g is 10, cos of 60, that is equal to 1 by 2. So that thing is equal to 0.7 into 1 over 2 there, and that thing is equal to 0.35. So plus 0.35 is equal to 0.1a. Or in other words, tension minus 1 into root 3, that is root 3 over 2 plus 0.35 is equal to 0.1a. Now, if we solve this 1 and 2 simultaneously, question number 1 there is root 3 minus tension is equal to 0.2a. This is positive, this is negative, cancel out. So this thing will be equal to root 3 minus root 3 over 2 plus 0.35 is equal to point, add these to 0.3a. So acceleration is equal to this acceleration is equal to 0.524. So it will move downward the particle P and upward the particle Q there. Now the second part of this question is it is given that the plane BC is also smooth. The particles are released from rest, and in the direct subsequent motion, the tension in the string is root 3 minus 1 Newton. Find the magnitude of this acceleration of P as it moves on the plane, and also find the value of theta there. Since the particles are moving, so and both planes are smooth, so there is no frictional force on that particle. So for this particle P there, it is moving downward, so it should be equal to mg sine of 60 minus tension is equal to MA. Since M is 0.2, G is 10, sine of 60 is root 3 over 2, minus tension there is root 3 minus 1, because tension there is equal to root 3 minus 1 Newton. And that thing is equal to 0.2 into acceleration A there. So this should be equal to 2 over 2 root 3 minus root 3 minus 1 is equal to 0.2a. So root 3 minus root 3 plus 1 is equal to 0.2a. So 1 over 0.2 is equal to a, or a is equal to 5 meter per second square. For this particle Q now, tension minus m2g sine theta is equal to mass of that m1 into a there, and a there is we have calculated equal to 5. So tension there is root 3 minus 1 minus m2 is 0.1 into g into sine of theta is equal to 0.5 r. This is 1 sine theta, that means sine theta is equal to root 3 minus 1 minus 0.5. That thing is equal to root 3 minus 1.5. 1.73 minus 1.5 is equal to sine theta. Sine theta is basically equal to 0.23. Theta should be equal to sine inverse of 0.23. $13.29. Now the last question we are going to attempt. Now we are solving question number 7. A car of mass 1200 kg is traveling along a straight horizontal road. The power of the car engine is constant and is equal to 16 kilowatt. There is a constant resistance to the motion of this magnitude 500 Newton. Find the acceleration of the car at the instant when the speed is 20 meters per second. We know that power is given, which is equal to 16,000 kilowatt, 16 kilowatt. So that will become 16,000 watt. But power is equal to driving force into velocity. So power is given there, that is equal to 16,000. Driving force we don't know, and the velocity of that particle is known to us, that is equal to 20. So driving force will be equal to 16,000 over 20, or that thing is equal to 800 Newton. Now, driving force minus the resistive force is equal to net force MA. As driving force is 800 minus resistive force is 500, Mass of that particle is 1200 into acceleration A there. So acceleration A will be equal to 300 over 1200, or it is equal to 3 over 12, or 1 over 4, or that is equal to 0.25 meters per second square. This is the first part of that question statement there. Now, the second part is assuming that this power and the acceleration resistance to the motion of the cars are unchanged, find the steady speed at which the car is traveling. We know that power and the resistance force remains unchanged. So power is basically equal to 16,000. So driving force for that portion will be equal to, as power is equal to driving force into velocity. So driving force will become power over velocity. Power is there 16,000 over velocity we don't know, that is V there. But driving force minus resistive force is equal to ma, but it is moving at a constant speed, so acceleration will be equal to 0. So driving force will be equal to 16,000 over V. My resistive force is already there, which is 500, and that is equal to 0. So 16,000 over V is equal to 500, or V is equal to 16,000 over 500. So V is equal to 160 over 5. So that is 32 meters per second. We have to show it on this part B of this. The car comes to the bottom of the straight hill of the length 316 meter, inclined an angle to the horizontal of sine inverse of 1 over 60. The power remains constant at 16 kilowatt, but the magnitude of the resistance force is now more longer constant, and it has changed so that the work done against the resistance force is ascending the hill is 128,400 joules. The time taken to ascend that hill is 15 seconds. Given that the car is traveling at a speed of 20 meters per second at the bottom of the hill, find the speed of the top of the hill there. Since the car is moving from bottom to the top of the hill of 316 meters, and power is same as this 16 kilowatt, which will be 16,000 watt, but power is equal to driving force over time. So this applies that driving force will become power into time. So that thing will be equal to 16,000 into time there is given equal to 15 seconds. So that is the driving force of that engine there. Now, as it is moving upward, let's say it is gaining a height h meter, then h over 316 is equal to sine theta. So h is equal to 316 into sine theta, or that thing is equal to 316 into sine theta is 1 over 60. So that is the height gained by that engine there. So we know that driving force minus resistive force is equal to change in kinetic energy of the system plus, because it is gaining height, so it will be mgh there. Now driving force is basically equal to 16,000 into 15 minus resistive force is there, which is mentioned as 128,400. Half mass of that particle is 1200 into v square we don't know, and u square is there at 20, plus n is there as 1200 into g is 10 into height there is 316 over 60. And after doing all this calculation, then the velocity of this equation will become equal to 21.9. So this is the velocity of the particle of this vehicle at the top of that hill there. So this is the final question of this 7 for this work power energy of this topic. So we have solved all questions of this M1 paper of year 2023. And if you have any questions, you can write the comments on that.